program status register. As we all know that one, whenever we are executing the program, we should know what is the status of that one. Basically, we call that as PSR, program status register. It's been divided into 3 subcategories. One is APSR, IPSR, and EPSR. APSR, it deals with the application status, program status register, application program status register. Second one is IPSR, that is interrupt program status register. And third one is EPSR. These are the 3 different types of PSRs which are available in your ARM Cortex-M3. The 3 PSRs can be accessed together or separately. The PSRs can be accessed together and can also be accessed separately using the special register access instruction called MSR and MRS. MSR and MRS. You have to be very, very careful when you are using this particular instruction. This is a special instruction which are available in your ARM Cortex-M3. That is MSR, MRS. Here, move. M means move. RS in the sense register to special register. Move, register to special register. Always you have to come from right to left. Right to left only you should consider. Don't say that one MSR means special register to register. You will be having a confusion here. Always come from right to left. Move from the general purpose register, what we are in R0 to R12. From there, we can move to special register, special purpose registers. Okay. Similarly, MSR, sorry. Okay. This is register to special purpose register. MRS is special purpose register to register. So using these 2 registers, we are in a position to identify what type of status registers we are having over there. Whether we are using APSR, whether we are using IPSR or EPSR, or are we using all together. When they are accessed as a collective item, the name is XPSR. So already it's been covered. This is where the instruction comes into picture. You can read the PSRs using the MRS read. That is status to the special purpose register to your general purpose register. You can read from the special purpose register. That is using MRS instruction. You can also change the APSR using the MSR instruction, but EPSR and IPSR cannot be changed. They are read only. Already it's been told. I'm repeating. EPSR and IPSR is only read only. APSR, that is application program statuses, is only read and also write. So MRS from the special purpose register to general purpose register. Example it's been given R0, APSR. That is read from this. Read from APSR to R0. We can also go for MSR. Read from special register to register, write into the special register. Write into the special register. From there, from the general purpose register, we can go for that. It can happen only for APSR, but we cannot do that one for IPSR and also EPSR. IPSR and EPSR, you can only use read operation. We cannot go for MSR, we cannot use. Only MRS we can use over there. That is MRS, R1, EPSR, MRS, R5, IPSR. We can only read, we cannot write. Okay, we can read from the executable program status register, that is execute program status register, and we can also interrupt program, we can only read interrupt program status register. That is what has been given. But write, we can go for MSR. That is only for APSR we can use. We cannot use for IPSR, we cannot use for EPSR. Now, program status register, it has been differentiated APSR, IPSR and EPSR. So how exactly they look into? Actually, your all the registers of your Cortex M3 is of 32-bit. We start with 0 to 31. 0 to 31, and all these bits are separated, means they're having their own operations over there. All the bits of the program status register, they have their own functionalities. As we all know that one, first 5, that is MSB 5 bits are there from the left to right. When you look into MSB, we call them as NZCVQ. NZCVQ, that is N means negative, Z means 0, C means carry, V means overflow. Okay, so in microcontroller we were using O, but in Cortex M3 we are going to use it as V. Okay, NZCVQ. When you look into, when you consider the PSR as APSR, when you consider PSR as APSR, then MSB 5 bits are NZCVQ and remaining bits are blank. Remaining bits are blank. If it is considered only APSR, because we can perform read operation, we can also perform the write operation. So only the 5 MSB bits are considered, that is NZCVQ, remaining bits are blank over there. If you are considering it as IPSR, that is interrupt program status register, then the first LSBs, 8 LSB bits are there. Those are exception number, because we are using it for execution purpose. There may be a chances of some interrupt which is available during the execution. During the execution, in the sense, it may ask for input, it may wait for some data coming from the memory locations, it may read from the memory, it may write into the memory. All those operations are going on. So we will be having LSB 8 bits are exception numbers and remaining bits are blank. Similarly, if you consider the PSR as execution program status register, we are having ICI, IT, thumb instruction. There are 2 ICI or IT is there and 1 thumb bit is there. The thumb bit is 24th, bit number 24, and other 2 bits are 26 and 25 is for ICT. Similarly, 10 to 15 is for ICT. When you club all these together as a XPSR, put all the 3 into single point. So at the top they are separately given, but at the bottom all put together we are considered. Now the question is, which one we need to write for examination? Assume that one they ask for the with a neat frame. It's a frame, we call that it's a frame with a neat data frame. Draw the PSR and explain each bit of the PSR. So you should write both. You should write APSR, IPSR, EPSR separately and club them together, and you should know that one. So it's easy when you know that one. First 5 bits MSBs are easily you can identify that one. Very next to that one we are going to have the ICT. Next to that one we will be having T. T is a thumb bit. We call this a thumb instruction bit. We call that one. In between 16 to 23, 16 to 23, that is 8 bits are there. They are blank. Next we are going to have the 20 to 25 will be having ICT and IT. And exception number as it is, we are taking it from the interrupt. Okay, so easily you can write it out. It is, you need to practice that one. Explanation has been given like this. As we know that one, MRS and MSR is the 2 instructions we are using for program status register. And we also come across only APSR can be read and write. IPSR and DPSR cannot be write. We can only read. But by using MSR and MRS, by using only PSR, we can perform read and write operation. Only PSR. Don't mention APSR, don't mention IPSR, don't mention EPSR. Just mention PSR. We can read from the PSR, that is program status register. Similarly, we can write to the program status register. Any clarification? We are using only PSR. We are not using a specific type of the PSR. We are generalizing the PSR here, where we can read and also we can write. And each bit has been explained here. ICI, interrupt continuable instruction. Interrupt need to be continued. Interrupt need to be continued. That is interrupt continuable instruction. We'll call that one IT. If then. Interrupt. Lot of interrupts are happening. That interrupts need to be continued. If the interrupt is there, then what should I do? Last bench, lot of interrupts is happening. Likith, Vinay, Manikanta. So interrupt one by one, interrupt is happening into the class. Even though interrupts are happening, Kranti, I'm continuing that one. Okay. So any interrupt happens in the program, inside the program, you should check that one. What is that ICI bit? If it is 1, what's going to happen? If it is interrupt is from Sharan, what's going to happen? If it is from Kranti, what's going to happen? What should I do? Whether I should stop the program or whether I should continue. So ICI, interrupt continuation, saying, okay, you can continue the interrupt. Whatever may be the interrupt, you be constant or you keep executing that one. Okay. So thumb instruction, it is for 16-bit or 32-bit, whatever it may be, depending on the type of the data. You can go for 16-bit instruction execution, or you can go for 32-bit instruction. Thumb state always 1. Is saying that one thumb should be always 1, where it can take care of the 16-bit also as soon as 16-bit comes into picture, or if it is 32-bit comes, it can take care of the 32-bit. Okay. When you compare the same PSR with the older version of the processor, that is ARM7. ARM7 was one of the popular processors we were using in almost all the electronic devices. Currently, ARM Cortex-M3 is the new advanced version. Okay. Before that, we ran ARM7. What are the differences they ran over there? So in ARM Cortex ARM7, we ran a special bit called modes. M bit, we call it mode. There are 7 modes for there. User mode, system mode, supervisor mode, interrupt mode, fast interrupt mode, error mode, exception mode. Interrupt mode. So, one more interrupt. We have to continue. What I mean by interrupt, we should continue that one. We should keep executing the program, such that the program will be executed successfully. The program needs to be executed successfully. Output should be good. Usually, previously there was a previous syllabus. If you look into the previous syllabus of embedded system, we were teaching ARM7. There we were in depth. We were teaching about the modes. There are basically 7 modes for that. As I said, we have a user mode. User mode is first one. And in that one, set of registers are going to be used. In user mode, almost all the registers we are going to use there. R0 to R1, ESR, stack pointer, link register, and also program counter, everything you are using over there. System mode. User mode, system mode, both are similar. Both are similar, but we are just checking it out. Mode bit just showing that whether it's a user mode or system mode. The mode, which mode you are using. Based on the mode, the system is going to, the program is going to execute that. User mode or system mode. Next one is interrupt mode. In interrupt mode, what's happening? Only interrupt bits are going to be considered, interrupt registers are going to be considered, all other user registers are not considered. R0 to R1 are not considering. R0 to R1 are not considering, only interrupt bits are getting executed over there. And since it is not there in our syllabus, I am not going in depth of that one because mode itself is removed. The mode itself is being removed in your ARM Cortex-M3. The mode M bit field is gone. It is not there in your PSR. Previously in ARM7 CPSR, the current program status register, we were having a bit called mode bit. But in ARM Cortex-M3, we don't have mode bit at all. Okay. Some bit is moved to bit number 24. Bit number 24, here we are having a T. We are having a T. Okay, here. When you look into the previous diagram, see here, bit number 24 has been given as T here. Previously, we were having ICT here. ICT, IFT. Okay, in the cortex, in the ARM 7, in ARM 7, bit number 6 was the T, but it has been moved to 24th bit. That is the difference we are having with respect to ARM Cortex M3. Even though some bit was there in the previous version, it was there in the bit number 6, but now the thumb bit has moved to bit number 24. Manikanta. Interrupt status I and F, that is I means interrupt, F means fast interrupt. I means interrupt, F means fast interrupt. Both are interrupts only. Fast interrupt is going to other fast compared to the interrupt. Some of the interrupts are slow, some of the interrupts are fast. How? Some of the interrupts are slow, some of the interrupts are fast. How we can differentiate them? If the interrupt is coming from outside, external interrupt, that is slow. If the interrupts are internal, inside the processor, inside the your cortex M3, then it is fast interrupt in call that place. Okay, so if it is external interrupt, it is slow. Simple interrupt will call that. But maybe from external devices at both peripherals what they are connected, they are giving the interrupt that causes the interrupt. Normal interrupt will call that. If the interrupt is between inside the operations, inside the processor, then we call it a fast interrupt. It may be cache memory which is connected. It may be PCM, tightly coupled memory. Okay, from those memory, because memory is already out of bound, we call that. When having some data, some 100 KB of data is there, but my cache memory is only 10K. My data is 100K, cache memory is only 10K, so it's not possible to put into the cache. Okay, so it's an internal operation, internal interrupt we call that, from fast interrupt. This is one small example I am giving over. Okay, so there is interrupt field is there, fast interrupt field is there. We call this a field, each bit is a field. So based on the type of the interrupt, I will be 1 or 0 or it will be 1 or 0. Okay. Similarly, IFB bits are replaced by the new interrupt mask register called primary mask, which are separated from the PSR. There are primary mask, fault mask, base primary. These are the three different errors are the means bits are there. You are going to be used. So see here, they are given two differences between both ARM General and ARM 7. NZCV was there previously, now NZCVQ is there. The difference, it's not required for you to write the exam. For example, it's not there, only for difference purpose you should know that one. So interrupt mask register, we are having the primary mask, we are having the fault mask, and also we are going to have the base primary mask registers are used to disable the exceptions. The primary mask and base primary registers are useful for temporarily disabling the interrupts in timing critical tasks. An OS could use fault mask to temporarily disable fault handling when the task has crashed. If any problem comes into picture, it's going to ask. In this scenario, a number of different faults might be taking place when the task is crashes. Once the core starts cleaning up, it may not want to be interrupted by the other faults caused by the crash process. Therefore, the fault mask gives us the OS kernel time to deal with the fault condition. So, three different types of interrupt mask register: primary mask, fault mask, and also base primary. These things are going to be used for how exactly we can handle the interrupts over there. See here, they have clearly mentioned what will be the value of primary mask, what will the value of fault mask, what will the value of the base primary. Based on this, we are able to mask the interrupts generated either from the internal or external. To access the different types of the interrupt mask, how to do, what are the instructions we are supposed to use? I need to set the mask bit, or I need to clear the mask bit, or I need to get it from that one. Set, clear, and get it. Get base primary, set base primary, disable. These are the three instructions we are going to have that one. Get in the sense, read from the particular mask bit. Set, we can write into that one. Okay. So instruction, you should know that one. Already we are having a bit, primary mask bit is there. Some value is available in that one. I need to get it from that. If you are getting it from that, you need to store that one to some variable. When you are reading, it should be stored to some variable. Directly you cannot read and keep it aside. We should store that one to last bench. Manikanta. This proposal. In on that. This one. Yeda mutkonde. Yeah. You can learn. ತುಂಬಾ ಕೆಟ್ಟ ಪದಗಳು ಬರ್ತಾ ಇದೆ ಬಾಯಲ್ಲಿ. ಅವನು ಯಾರು ನಡ್ತಿರೋದು? ಏನಪ್ಪ? ಸೋಮವಾರ ಬೆಳಿಗ್ಗೆ ಈಶ್ವರನ್ ನೋಡ್ಕೊಂಡು ಬಂದಿರ್ತೀನಿ ನಾನು. ಕೆಟ್ಟ ಪದಗಳು ಬೈಬಾರ್ದು. ಆದ್ರೂ ಬಂದ್ಬಿಡುತ್ತೆ ನೀನು ಹೋಗಿ ನಾನು ಹೋಗಿ ಎಲ್ಲ ವಿಡಿಯೋದಲ್ಲಿ ಹೋಗಿ ಆಗುತ್ತೆ. ಕೂತ್ಕೊಳ್ಳಿ. See, already a mask bit is there. Basically, three mask bits: primary mask, fault mask, and also base primary. I've already told you what is these three bits are there. If you want to read from that particular primary mask, we are reading. Get it. Get is the instruction for read. Once you get it, you have to keep that one or store that one into some other variable. So x equals, clearly see here, x equals, see the underscore which is being used here. Underscore which is used, it is not a single, it is double. Get, here it's going to be single underscore, then we are going to use base primary. In the program, most of you will be doing the mistake here. You will be knowing the program, but instead of giving double underscore, you might have given a single underscore. See the difference in the printed format also. Here it's a single underscore, a small one, it's going to be bigger. So it's a double underscore, it's going to be. You are supposed to give double underscore when you are using the get or put or set. Get or set. See that everywhere it's going to be get. You are reading from all the three different types of mask bits and storing that one to a variable called x. Similarly, if you want to set whatever the value of x is there, that value you are setting to the particular mask over there itself. So set mask also is going to be used. Set base primary. Either you can use y or you can use x or whichever the variable you are having, that value you can use it over there itself. Similarly, disable. I don't want to use that particular existing mask. I can disable that one. Existing interrupt, I have to disable that one. You can go for disable IRQ, interrupt request. IRQ in the sense interrupt request, will call that one. Interrupt is requesting, don't request, disable it. Okay. Similarly, enable IRQ. You can enable the IRQ bit. So interrupt request is there. You can disable or you can enable by using disable instruction and also enable instruction. So these are the different types of instructions which are available, which can be used. Either you want to read from the interrupt bit, or you want to set the interrupt bit, you want to disable, you want to enable. Anything can be done. First you need to enable, then only you can read or you can write. If you disable, you cannot read and you cannot write it over there. Interrupt mask registers, once again using MRS and MSR, you can go for it. Already it's been discussed. Okay, whenever you want to read from the special register, you're going to use MRS. Whenever you want to write into the special register, you're going to use MSR. Okay, so read and write, you can go for it. Base primary can be read, base primary can be write, fault primary can be read, fault primary can write, and also primary mask, that is primary mask also can be read and write. All the three can be read and write. This is up to here is the interrupt. Three different, that is PSRs. In PSRs, we are going to call the three different types of interrupts. Now we have to move to the third type of the register, special register, control register. The control register used to define the privilege level and the stack pointer selection. Privilege. What privilege you are having? What is the privilege? What is the we can call what I can say? It's like read or write operation. Okay, execution operation. All those things comes in the privilege. So control 0 or control 1, two bits are there. Control 1 is the first bit. Control 1 is the first bit. The stack status, if it is 1, alternate stack can be used. That is, there are two stacks are there. One is MSP and PSP. Memory stack pointer and process stack pointer. Two stack pointers are there. If it is 1, you can go for the alternate stack user. Means PSP you can use. Instead of using MSP, you can go for PSP. 0 indicates you're using the MSP. If it is 1, you're using PSP. If it is 0, you're using MSP. Similarly, control 0. 0 indicates the privileged. 1 user state. That is privileged in thread mode and user mode, we'll call that. In the Cortex M3, the control 1 bit is always 0 in handler mode. However, in the thread or base level, it can be either 0 or 1. Okay, by default it is 0, but in thread level it can be 0 or 1. This bit is writable only when the core is in thread mode and privileged. Whenever you want to write that one, it should be in the thread mode. In the user state or handler mode, writing to this bit is not allowed. You cannot go for it. If it is user state, you cannot allow that one. Aside from writing to this register, another way to change this bit is change bit 2 of the LR. Bit 2 of the LR, that is link register when the exception returns. So get control, set control, same thing, same as your get primary mask, set primary mask. Similarly, we are going to have the get controls, set control. We can read and write, both can be done. I told you operating modes. There are different operating modes with respect to ARM Cortex 7, ARM 7. Now ARM Cortex M3, we're having two operation modes, handler mode and thread mode. It's saying handler mode and thread mode, two modes are there. Operation modes, thread mode and handler mode determines whether the process is running in a normal program or running an exceptional handler, like an interrupt handler is system exception handler. There are two different modes. One is the thread mode, another is the handler mode. If it is a thread mode, it's going to be different. If it's a handler mode, it's going to operate in different mode itself. See, handler mode, thread mode. When running an exception handler, it will be in handler mode. When not running an exception handler, it will be in thread mode itself. See, this is also one of the very important question which is asked in your main examination. Operating modes. How the operating modes comes into picture. With a diagram, explain the operating modes of the ARM Cortex M3. Privileged handler, privileged thread, user thread. These are the three different operations or threads or modes, we can call that one. You should know how to do, how exactly they're going to deal with. See, all these things you have to write for this exam is question. If it is privileged handler, privileged thread and user thread, how it's going to move. Step by step, you should explain that.